The luminous intensity I candelas of a lamp at varying voltage V is given by I equals to 4 times 10 to the negative fourth power times V to the second power. Determine the voltage at which the light is increasing at a rate of 0.6 candelas per volt. Okay, first let's understand the meaning of the luminous intensity. So the luminous intensity means the light we get from a lamp. Usually the light we get from a lamp or the luminous intensity is measured in the unit candelas. And it will be mentioned with the alphabet I. So whenever we have the word alphabet I, so I have to understand it represents luminous intensity or the light we get from a lamp. So here, when I look at this function, I is a function of V. That is, the light of the lamp is a function of voltage because the light of the lamp will change with respect to the voltage it receives. Okay, now let's look at what we have to find actually in this question. So we have to find the voltage when the light is increasing at a rate of 0.6 candelas per volt. That means the light is changing at the rate of 0.6 candelas per volt. Okay, here from the given information, if I want to find the rate of change of light, how to find the derivative of this I with respect to V. So because I represents the light we receive, the light we get from the lamp, and since it's a function of V, we have to find the derivative of this I with respect to V, that is voltage. Okay, let me write the given function. I equals to 4 times 10 to the negative fourth power times V square. Okay, now I find derivative of this I with respect to voltage. So actually I can find derivative of this I only with respect to voltage because I is a function of voltage. Okay, here on the right side also we have to find the derivative with respect to the variable V. So here 4 is a constant, 10 to the negative fourth power is a constant. Both the constants are multiplied by the variable. When I find derivative, if constants are multiplied by the variable, I have to keep the constants as it is, and I have to find the derivative of variable alone. So when I find the derivative of this V square with respect to V, it will become 2V. Okay, let's simplify this. dI over dV equals to 4 times 2 will become 8. 8 times 10 to the negative fourth power times V. Okay, now I got the rate of change of light with respect to voltage. So dI over dV so gives us a rate of change, the rate at which the light is increasing or decreasing. Okay, here the question, we have an information, the question, that is the light is increasing. Increasing means it's changing at a rate of 0.6. So we can plug in this value 0.6 for this dI over dV, because dI over dV represents the rate of change of light. Since it is given that the light is increasing, so we have to take this value as positive. That means the value of dI over dV has to be positive, because if dI over dV is positive means the rate of change of I or the rate of change of light is increasing if this value is positive. So we can plug in 0.6 for this value, because that is what is given for rate of change of light. That is light is increasing at a rate of 0.6 equals to 8 times 10 to the negative fourth power times V. Okay, now when the rate of, when the light is increasing at a rate of 0.6, we have to find the voltage. That is, we have to solve for V in this equation. Okay, let me write the equation over here. Okay, to solve for V, I have to get rid of this stuff over here. For that, I divide both sides by 8 times 10 to the negative fourth power. So this one will cancel out. I get 0.6 over 8 times 10 to the negative fourth power. Okay, so if you have a calculator, we can use calculator to simplify this one. But here I'm going to do it without calculator. So the first thing what I'm going to do is I'm going to move this 10 to the negative fourth power to numerator. So if I move any power from denominator to numerator or numerator to denominator, I have to change the sign of the exponent. So here the sign of the exponent over here is negative 4. When I move this power 10 to the negative fourth power to numerator, it will become 10 to the positive fourth power. So 0.6 times 10 to the fourth power over 8 equals to V. Okay, here 10 to the fourth power. When I multiply this value by 10 to the fourth power, the decimal point over here has to be moved 4 digits to the right. As we have only 1 digit to the right of the decimal point 6, we need 3 more digits. So for that, I'm going to take 3 zeros. So 6000, that is 6000 over 8 equals to V. So when I multiply 0.6 by 10 to the fourth power, I'll be getting 6,000. Or we can even convert 10 to the fourth power as 10,000, and we can multiply 10,000 by 0.6. We'll be getting the same result, 6,000. Okay, now what we can do is we have to divide this 6,000 by 8. 8 goes into 8 one times, 8 goes into 6 0 times. So we can take the number formed by the first two digits, 60. How many times 8 goes into 60? 7 times. Because 7 times 8 is 56, and we have 4 left in 60. That 4 can be taken along with the next digit, then it will become 40. How many times 8 goes into 40? 5 times. And we have 1 0 here that can be taken over here. So V is equal to 750 volts. So when the light is increasing at a rate of 0.6 candelas per volt, so the voltage is 750 volts.